Hello, and welcome to another episode of The Bike Shed, a weekly podcast from your friends at thoughtbot about developing great software. I'm Sally Hall.
And I'm Joel Kenville. And together, we're here to share a bit of what we've learned along the way.
So, Joël, what's new in your world?
I've been doing a lot of work in TypeScript recently, and something that's really interesting about a type system is that it often takes a lot of things that are implicit in your program and makes them explicit. And something that I've been digging into a little bit is how much uncertainty you add to your program when you index into a collection. So this might be taking an array and using an index to pull an item out of it, or taking a map. This is the equivalent to a hash in Ruby, and indexing a key out of that, because you're never guaranteed that you're going to get an item back. You might get undefined. And a type checker tries to keep you honest and will say, hey, did you remember to check for the case where that value is not present?
I have just started experiencing that as my first project with TypeScript.
I feel like, and I've been sort of like categorizing some of this uncertainty, taking a little bit of inspiration from Fred Brooks' paper, No Silver Bullet, where he sort of breaks down complexity in software into essential complexity, which is sort of inherent to the problem you're working with, versus accidental complexity, which is complexity you've introduced by your particular choice of implementation. And I feel like a little bit of that applies to sort of nullability or uncertainty that you've introduced to your program. Some of it is just inherent to the software you build. Like if you're dealing with user input, you can't trust that. You can't guarantee that they submitted all the fields on a form, things like that. And so that's inherent. But there's other things that are sort of implicit to the choices you've made for your implementation. And I think that oftentimes choosing an algorithm where you're indexing into a data structure can introduce some of that accidental uncertainty to your program. And so now you either have to tell TypeScript to shut up, or you've got to like add all this extra handling, perhaps with a comment that says this should never happen, or you're like dealing with sentinel values, or you're doing all these hacky things to sort of like just make the compiler happy. Or you have to consider a different algorithm where you don't index.
Yeah, that's interesting. And the idea of like, do you tell TypeScript to shut up? Do you deal with it just enough that TypeScript stops complaining about it? Or do you actually address the root of like, what am I doing here and what did I intend to do here? You know? And I think some of that comes down to like, what are you working on and how much time do you have to dig into a totally different algorithm where you don't face this problem?
Some of that is maybe also sort of upfront, right? Once this is a way of thinking that you're used to, maybe you don't reach for very index-heavy algorithms upfront, or you're much more aware of the risks that go around them, the edge cases you have to handle for an algorithm that's very index-heavy.
Yeah, this is actually making me realize that like indexing something is one of those things that I always like see as a flag, not necessarily a red flag, but maybe a yellow flag when I'm looking at code.
Okay.
It's a little bit like if you see hard-coded strings everywhere, sometimes that's a flag for me to go, is this something that we could be doing differently? And so whenever I see like an indexed array in a piece of code, my first thought is also always like, why are we doing that? Is there a different way to do that? How do we know what index is right? Because the other thing is that I don't really trust myself to pull out of my brain exactly the right way to index the element I'm looking for, you know?
That's the danger of telling TypeScript to shut up, right?
Yeah.
Is the trust me, I'm going to do this right. There will not be a bug here. Will backfire on you pretty frequently.
Yeah. Yeah. The phrase, don't worry, I know what I'm doing, is almost never true.
I feel like when I was in college and I had to do a lot of C++ projects, and, I'm newish to C++, and I'm not a very good programmer because I'm a college student. And the number of times where I was doing some sort of iteration pattern using a classic for loop and had some sort of off by one error in my indexing or some other subtle like boundary condition were really high. And then post-college, when I discovered Ruby, and I was like, oh, there's just an each loop where you can like iterate through a collection and you never have to bother with indexes. That's a whole class of bugs I never have to think about. That was one of the things that sold me on Ruby, was that, oh, I can do this thing without having to worry about this class of bug.
Yeah, and that's probably why it feels like a flag to me, is that I mostly work in Ruby, and in Ruby you very rarely need to do that. There's tools built in that let you. I feel like the enum class is very powerful in Ruby. If there's something you want to do and you're trying to write it yourself, there's very likely something already built in that can help you out with that.
Exactly. It's definitely a smell to not be using the, I guess, idiomatic way of doing things.
Yeah.
And in TypeScript or JavaScript, similarly, more modern versions have the ability to iterate over a collection without having to manually do it via indexes. So JavaScript has that for in construct that's a little bit like Python's list comprehensions. And arrays have a for each method that will accept an anonymous function to iterate over an array. And so both of those allow you to go through an array and not have TypeScript yell at you in the way that it would if you were doing classic for loop. In some ways, I guess maybe in this case, the type checker pushes you towards using more built-ins rather than going low level and doing it all yourself.
Yeah, which is super helpful.
So, Sally, what's new in your world?
Well, funny enough, also TypeScript related, which is that I tend to work a lot more with Ruby and Rails than with any other language. But I'm currently working on a project with a lot of React, and we're using TypeScript. And I have mixed feelings about JavaScript in general, but TypeScript is really growing on me. It's at first it was very annoying because I didn't fully understand it, and it would yell at me about things that I didn't know why it was TypeScript's business to even be thinking about. But now I really like, first of all, the like type checker will say like, hey, this might be undefined or this might be null. Are you sure you want to do this? Um, but I'm also finding that it's just really nice, especially with the like more complicated parts of the app, to know exactly what shape something is supposed to be. You know, that's one of the things that I occasionally will get frustrated with in Ruby, is looking at some code and going like, okay, I don't know what kind of object I'm supposed to pass to this, or what kind of object this is going to give me back. If it's not something I'm familiar with, or it's not well documented, or it's just not clear. And I like that with using TypeScript, I generally have a pretty good idea of what to expect and where something's coming from, as far as like what kind of object is this.
So the idea of types as a documentation is really
Yes,
appealing to you.
it is really appealing to me. Yeah, types as documentation, and using TypeScript or the TypeScript checker as a way of knowing that like things are at least going around in the shape that they're supposed to. I've also find it really helpful sometimes when I, um, realize I need to, add an attribute to something, and I add it in one place, but there are other places where I need to account for it. And without TypeScript, those would just be undefined or null, and that would be a surprising bug later on when I'm like, why isn't this working the way it is? Because it's not expecting this attribute and it's there, or because it is expecting this attribute and it's not there. And so I think it just helps me be a little more thorough too.
Do you find that having types has impacted the way you test?
Oh, that's a good question. Not entirely. We're using, like, we've got a React front end using inertia with a Rails back end. So I tend to sort of lean towards testing the way that I'm comfortable. So we are writing front end tests for the components we're creating, but sometimes I'll just go with like, this really makes more sense as a Ruby system test or Rails system test. And so like in general, just because of where my comfort is, I'm maybe not writing as many tests using JavaScript as I could be. So it hasn't really affected it, but it's still early, and I could see that affecting the way I write tests for sure.
Do you think that maybe the types give you confidence that's similar to what you would have from unit tests in the front end code? And maybe that helps you feel not quite as much the need to have like a really thorough suite of unit tests on the front end?
Yeah, I do think the TypeScript has given me some confidence. So some things that I feel like I would have needed to manually check in an unit test, I know are already checked by TypeScript. So I can sort of avoid those or skip over some of the more tedious edge cases that handle with just having an untyped language, which has been nice.
I guess that's one of the really nice things about having a type checker that does know about nullability is that you get to mark in your program, these are the places where the data is guaranteed present. And these are the places where it may or may not be present, and we need to do presence checks.
Mm-hmm.
And the type checker then guarantees that those are true. So in a unit test, if you were to write a unit test, you don't need all those edge cases that we would write in Ruby, like, oh, what if you pass in nil? Because that is an edge case that has already been eliminated by the type checker.
Yeah. Yeah. It speeds things up a little bit. And it's nice to be able to check those off my worry list and worry about other things.
I mean, that's exciting to see that you're diving into more of the front end, getting into TypeScript. I'm sure we'll hear more about that over the course of the
Mm-hmm.
season as you sort of unlock new sort of aha moments. And maybe that's a thing to check in on in our recap episode. The hey, now you've been doing TypeScript for 12 weeks. Sort of, here were your initial thoughts. How are you feeling now?
Yeah, it will be interesting to see. Does it continue to grow on me or does our relationship turn sour? Stay tuned.
So, learning types when you're getting into TypeScript is sort of one of the many tools that we have to learn as programmers to sort of get good at our job, especially if you're writing TypeScript. Um, Something I wanted to explore more today is a little bit of what is the skill in software development. I think that's sort of classically phrased as what exactly would you say you do around here?
I'm a people person. Yeah, I think that's a really interesting question and something I think about a fair amount, especially as the field of software development is always changing. But I feel like there's been bigger changes with AI tools and sort of like what's my job and what's the tool's job.
Yeah.
Um, and then I also, one of my kids is actually considering software as a career. And so thinking about sort of what are the ups and what are the downs and which parts of it appeal to him and align with his interests and skills has also been interesting conversations. And I think what I think the skills in software development are, I think maybe would be a little surprising, but might sound kind of generic and silly. And that is evaluating information and solving problems.
Let's break that down a little bit. How does that maybe differ from, I don't know, like a strategy consultant? Uh,
It's possible that it doesn't entirely,
ooh, all right.
I sort of brush aside the ideas of like familiarity with a language or syntax or like knowing exactly which characters to type because that's less a skill and more just like familiarity, really. Right? You can learn a context, but whether or not you have the skill to then use those tools that you've learned is different. So first of all, evaluating information. And I've noticed this with, I used to work at a coding boot camp, and something that I saw a lot of really new developers do is when they get an error message, they don't read it and they panic. Right. But like, I think for more experienced developers, we know that error messages are your friends, right? Especially in a good system, the error message is going to tell you what went wrong. Hopefully, it'll tell you where it went wrong. And sometimes it's even going to give you a suggestion for how to fix it. So being able to read that error message, understand what the error message or like, the system that generated the error message, what they think is wrong, and then use your context clues and critical thinking skills to go, is this actually what's wrong? Or is this sort of a red herring and there's a problem and this is just happens to be the layer where it exploded enough to give me an error? A React thing I've been seeing a lot in my tests is that sometimes I'll get an error that like a color is undefined, which feels very weird. And I've come to realize that when I get that error, it usually means I haven't mocked something I need to mock in the test.
Fun.
Yeah. But if I didn't have the critical thinking skills to sort of dig into that and explore around it, I could get stuck on like, how do I define this color? When that's actually not the problem at all.
So I guess there's sort of like almost, I don't know if I want to call it data, but there's sort of a bunch of facts you need to know about your particular programming language and environment.
Mm-hmm.
But just knowing those facts doesn't make you a good programmer. Those are often things that you focus on when you're very junior. But then
Mm-hmm.
what you do is you layer on that critical thinking that you're talking about, and you sort of add that logic on top of the facts that you know, and that's what takes you to the next level.
Yeah. Yeah. And I think it's also, none of us are born with a complete language syntax in our brain, obviously. Like all of us look things up on a daily basis in our jobs for the most part, I think. And so, yeah, I think you mentioned before the idea of like, oh, I just Google things. That's my whole job as a software developer. And I have a sticker somewhere from a spoof on an O'Reilly book called Copying and Pasting from Stack Overflow, which is like fun to joke about. But that's really like, that's sort of part of what I mean by evaluating information. There are any given question on Stack Overflow is going to have a variety of answers. And how do you decide which one is correct or if any of them are correct? Um, and I think that's the skill that we develop over time as developers is sort of an instinct for like, that looks reasonable. I understand why that would fix my problem. And I know how to try it safely versus I'm just going to copy and paste this into my Chrome developer console and hope that my computer doesn't explode. And to me, I feel like that's one of the things that will hopefully keep us employed despite AI for a little bit longer. So AI can read everything and, parse it and put it back together in various ways. But from what I've seen, it's not great at like critiquing that information yet and evaluating sources of information. And so that's where I think the human skill is still really relevant.
I'm interested in digging a little bit further in the idea of programmers as sort of expert Googlers, because I feel like that's often a thing that is a source of insecurity for maybe more junior developers who feel like the way you're a good programmer is having an encyclopedic knowledge of a language and syntax. And therefore having to Google is a like admission of failure.
Mm-hmm.
And on the other side of that, I often see sort of more experienced developers trying to sort of maybe address some of that fear by telling junior developers, no, like I Google all the time. Like that's basically my whole job. I do all the Googling. And in the one sense, that seems true, right? We look up things all the time. But on the other hand, it's also not, in that we've sort of gone beyond the phase where the core of our competency is that knowledge. And now we're just doing sort of reference lookups
Yeah.
in order to allow us to do our actual job, which is that critical thinking.
The idea of a reference lookup as a specific kind of Googling is interesting to me. Like, how would you describe Google searches as a software developer that aren't reference lookups?
I feel like most of them are reference lookups, depending on how strict you are with the term.
Mm-hmm.
Um, Oftentimes, I'm just using this as a way to like find the documentation on a particular method.
Yeah.
Or maybe I don't even know the name of the method, but I'm like, what is the method that allows me to filter down a collection or
Yeah.
something like that? Especially if I'm in a language where I'm less familiar, where I'm like, oh, well, Ruby has this, but what is the equivalent in this other language? Sometimes
Yeah.
you're, Googling error messages. I guess that's a form of reference lookup-ish. But the things you're looking for might be more blog posts or Stack Overflow answers than they are particular like reference documentation.
Mm-hmm.
Sometimes you're Googling more for like, hey, here's a general problem. what are sort of common solutions to this? And it's more of an exploratory, like, let me understand the solution space. Um, and that might be for sort of libraries, like, hey, I'm doing authentication in Rails. What are the like 3 common ways that people do that? Um, or it could be for something more generic, and you want to see sort of what are the types of abstractions that people are using, or how do people tend to approach this problem. And now you're sort of much more in the realm of getting opinions rather than getting reference material. So I don't know if that all falls under reference lookups.
Yeah, I guess it sort of depends on how you define it. Do I just want, show me the syntax for looping over an array in this language, or do I want show me the various approaches to authentication? So different kinds of references for sure. And I think it comes down to, I started to realize as you were talking that like a lot of that comes down to what question are you asking and how are you asking it? And so I think that's another, maybe not entirely different, but another aspect of a skill of a software developer. And for us as consultants, even more so, is asking good questions, right? So if you're talking to your client, or if you're talking to a colleague, or if you're talking to Claude, or if you're talking to Google, um, the information you get back is going to be largely based on what you asked, right? So if I'm Googling like JavaScript array loop, I'm probably going to get some specific things about syntax, but I'm not going to get maybe higher level things about like, how do I know when to use this versus that, or what are the upsides and downsides and things like that. And like, you're going to have to think about what information am I really looking for as part of asking your question. And with consulting, it's similar to say, not saying, hey, do you want this to be red or blue, but saying like, what do you want this color to communicate? Right? Those are 2 different questions, and you're going to get very different answers.
I have a note in my personal note-taking system where the title is Consultants Are Professional Question Askers.
Yes, we are. And I think that's true of software developers who aren't consultants too. Like very rarely are we writing software in a vacuum alone for ourselves alone. So even if you are a one-person team developing software alone, if anybody else is going to use it, you've got to ask yourself some questions about how they're going to be using it.
Yeah, and even oftentimes people will do that sort of old school, like in a paper notebook, right? You're faced with a large problem and you're like, let me like write down what are my open questions about it, and then that'll help me think through the problem.
Yeah, and can often lead to, the rubber duck situation we talk about, where just through the process of me writing down what my questions are or saying them out loud to you or a rubber duck on my desk, um, I come up with answers. Sometimes writing the good question or developing the good question turns into the answer, and you don't actually end up needing to ask anybody else or to Google it.
I'm going to take this in a slightly maybe weird direction.
Ooh, I'm excited.
This idea that one of the key developer skills is asking good questions. And a little bit of that goes into like, how do you Google for things well? In an AI age, could that also translate to like being good at writing prompts?
Oh, absolutely. I've heard the phrase prompt engineering, and that seems maybe a little overcomplicated, but it's also true. It's not going to answer the question that you didn't ask, but were thinking of. It's going to answer the question that you asked. Yeah, in your experience, what makes a good like AI prompt? Have you spent much time thinking about how you write those?
I've definitely found that one thing you have to be careful with is that some AIs are very agreeable. Like they really want to agree with you. And
Mm-hmm.
so if you want an honest opinion, you have to phrase things in a way that will actually give you something useful. Um, I find it's often useful to ask about sort of the a landscape of solutions. So
Mm-hmm.
that question, like, "Hey, I have a problem X. Uh, what are sort of 3 or 4 common classes of solution for this type of problem?" This is if I'm in a more exploratory phase.
Right.
So it's kind of like asking Google, except that like with Google, you've got to like sift through a lot of results and it's just a lot of work to like find the pieces that you need. And something like ChatGPT might do that synthesis for you. Now, it might entirely miss a class of solution, which is something you have to be aware of. But then so would Googling, because maybe it's not on the first page of results. And so you might miss it that way as well.
Yeah. Or even asking a human. It could be that there's a class of solutions that the human you've asked, even if they're an expert, are not familiar with, or they don't prefer it, so they're not going to mention it for any number of reasons.
I had a situation like this where I was doing some kind of AI assisted development, and I was asking for like a pretty complex um, array transformation in TypeScript. And this is at a time where I was newer to TypeScript and I was leaning on an LLM to help me get to a solution. And I didn't like the way it built its solution. And I asked it for a broader, like, show me like different families of solutions. And it did, but I didn't like any of them. And at some point I had to say, hey, can you show me a like solution inspired by the way that like certain type of functional language would solve this? So I'm pretty sure that like the Haskell community does something that's closer to what I'm looking for. And with that prompting, all of a sudden it was like, oh yeah, that other thing, let me show you. And that was exactly what I wanted. And so I think having for myself a little bit of a sense of the landscape was useful, because then I could say, hey, I don't remember what the Haskell community does. And like it would probably take a lot of Googling for me to find exactly what I'm looking for and to translate it into TypeScript. But just giving it that pointer was enough for it to say, oh yeah, this other class that I forgot to even show you, how do you feel about this? And all of a sudden I'm like, oh, that is much closer. Now I can iterate on it and actually have something I like.
I feel like that's a great example of asking a question and then asking a better question. But it's also an example of the skill you use to evaluate all of the first answers, right? Like if you weren't a skilled software developer, you likely would have just taken the first one and gone with it. And it might have worked, right?
Mm-hmm.
But it's not going to be the ideal solution or the solution that fits in with all the other context that even if you gave to your AI agent or whatever you're asking, might not synthesize it the same way that you do.
Yeah. And in this particular case, some of the solution classes that it gave me were sort of overriding the type checker, which a lot of TypeScript devs are totally okay with. But that made me uncomfortable. So I was like, can we look at different approaches to the problem that are not overriding the type checker?
Yeah.
Some of them were sort of extremely verbose, or didn't compose very well with something else that I wanted to do. So yeah, like you said, that ability to analyze was really helpful. Sadly, I think another thing that's really valuable is just a little bit of that like personal like memory index of a little bit of what's out there. And what's
Mm-hmm.
nice with tools like Google, with tools like LLMs, is that you don't need to remember precisely what it is. As long as you just have enough of a fuzzy description of it, these tools can help bring it up for you. So in my case, it was a, hey, I feel like the Haskell community does this, has a solution for this. Can you show it to me? And that I found it immediately. Whereas if I'd never done any functional programming, I would have missed that entirely. And so would the LLM.
Yeah. Because the LLM has, massive amounts of information. It's making a lot of, quote, decisions on the background every time it answers a question of yours. And if you were asking about TypeScript and the solution you wanted wasn't Haskell, there's good reasons that the LLM wouldn't have reached for that solution, even though it's, translatable to what you were doing.
I feel like I'm seeing a bit of a tension here, in that we're saying that the core thing that is important about software developers is not that like sort of base knowledge and just memorizing facts. It's about that more like critical thinking. And yet, in order to be good at critical thinking, you need to build up a base of facts to work off of.
Yeah.
And maybe you can mitigate that to a certain extent via tools like LLMs, Google, good old fashioned reference books, where you don't have to memorize it all, but you do have to know just enough about the landscape to be able to like guide your searches.
Yeah. Yeah. It seems like there's sort of like this incremental approach where it's like you learn enough about the language to be able to ask a question, and then you get some answers and you evaluate them. And then as you work with it more, you learn more about it. and you're able to critically think about it more. And the more you understand, the better you're able to sort of evaluate the information. So it's critical thinking and information evaluation and asking good questions alone obviously is not going to write you an app. You also do need to kind of understand, what are the tools I'm using? What is the language? What are some specific gotchas or specific features or approaches that have historically worked in a situation like this?
And I think that's where sort of we as very senior developers have sort of like moved past a lot of things like syntax where, oh, I got the syntax wrong. I'll fix it. Or, maybe even an LLM can fix it for me. Or, Rubocop can fix it for me or some other tooling thing. And that's not really a thing we think about all that much because most of our thought is in the solution space versus someone who's more junior is putting the majority of their thought in, how do I structure this correctly? How do I get the syntax right? How do you think you sort of bridge that divide?
Yeah, that's interesting. And just it immediately made me think of when I was first learning to code and when I was working in a code school and helping other people learn to code. It's really hard to find good learning resources for that middle period. There's a lot of stuff online that'll guide you through learning the early stuff. And there's a lot of blogs and resources that will help you solve the more abstract problems once you're more developed. But there's not a lot of resources available for bridging that gap because it's really hard to do. And I think the answer for me, in my experience, is just keep practicing, keep failing and trying and asking questions and testing answers over and over again, which is not a exciting answer. But I think it's sort of like, it feels like a gradual shift from like mostly syntax thinking to more problem solving thinking or holistic architecture thinking. I don't know. What do you think? Did you have a way to bridge that gap other than just do it over and over again?
And if you can get a mentor or somebody to support you, that's really great. And that's ideally a company is doing this for their junior developers, like giving you an opportunity to work with more senior people where you can sort of pick some of those things up. I think introspection is generally really helpful as well. Pausing and thinking like, hey, I solved this problem in this way today. Or I chose this solution this way. Why did I choose that? Learning to flex that decision muscle pretty early.
Mm-hmm.
Having to explain yourself. I think a great way of doing that is just explaining your rationale on in your PR description or in your commit message. And it doesn't have to be a whole essay, right? It can be a few sentences. But say, hey, I was faced with this problem. I Googled and found these like 3 different Stack Overflow solutions. I went with this one because I think that it has fewer security downsides, or it is a little bit more concise, or whatever your particular reasoning was. And it's okay to get the wrong answer. And
Mm-hmm.
maybe a more senior person will say, hey, I'm glad you thought this through. But you may not have realized this other solution is preferred for these reasons.
Yeah.
But it gives you like a small area to start flexing that muscle and to work beyond just the like memorize everything to critical thinker.
Yeah. And I think you can get some of the same benefits from reading other people's PRs. I've, heard junior developers often say like, well, I'm not qualified to review that very senior developer's PR. Like what do I have to tell them? Which, I think is only one piece of a PR review. First of all, you might have something to tell them. You might have an interesting thought that, differs from what they did. But also just reviewing it and asking questions and seeing how they thought and how they explain their thoughts and understanding how it fits in is hugely beneficial. Like feedback and error correction are not the whole point of a PR. It's also information sharing and just understanding.
One of the most powerful things you can ask as a junior developer is why.
Yeah. And I've been doing that a lot as I've been, getting more familiar with React, which I've always only used in bits and pieces. I'd say about half my comments on PRs that involve React recently have been, hey, I don't understand why you're doing this. And I'm new to React. Can you sort of walk me through this? And that has been super helpful.
I'd love to hear a little bit about what the experience is for you sort of going back into beginner mode, but you're not truly beginner because you have already such a vast knowledge of other software to build on. And so you can recognize patterns and be like, oh, this is like this other thing. And you also have the like critical thinking skills built really deeply. So like in some ways you're returning to beginner world, but in other ways you're very much not. What is that experience like for you?
It's been fun, honestly. Like I think a lot of software engineers love learning. Like that's part of why we're doing this. If you don't ever want to learn again, this is probably not a great path for you. So discovering new kinds of problems and new ways of approaching things, I think has been really fun. It's also been, kind of humbling to be like, I don't have any idea what this problem is and I don't know how to fix it. And I absolutely just need to ask for help from someone. It's also been really interesting because at the same time that I'm getting used to React, there are, pretty senior developers on the team who have never done Ruby or Rails before. So they're doing the same thing. And it's been interesting to see sort of the Ruby and Rails patterns I'm trying to bring to JavaScript and React and the other patterns that people are trying to bring to Ruby and Rails. And sort of noticing the ways in which what I'm comfortable with influences how I work with something I'm not comfortable with. Like I was saying earlier, that like I'm going to try to write a test in Ruby as often as I can.
Sort of the cross pollination you get there.
Yeah, absolutely. And it's the kind of thing that I'm really glad I'm doing it on a team. This is one of those times where like having people who are more experienced in what I'm working on has been enormous. I've had jobs in the past where I was the only developer, and that's a great way to not learn anything.
Just kind of stagnate.
Yeah.
So if like the thing that we do is not, being encyclopedias of language syntax, and to a certain extent, it's maybe having at least exposure to a lot of these things. So a little bit of indexing in our minds, and just sort of the raw ability to think critically and to break down problems and evaluate. How do you feel about maybe a kind of a middle ground, which is maybe not an encyclopedic knowledge of details like syntax, but maybe a deep familiarity with some of the big ideas of programming, things that you might call fundamentals, although I know that might be controversial. And this could be as far away as like, oh, you need to have a solid understanding of math, to, category theory would be good, to, hey, maybe it's good to read or to have, familiarity with some classic computer science papers, or sort of anything you want to fit in that box of like big ideas from the software world. Maybe it's some type theory.
Yeah. I mean, I think all of those things can be super helpful. I think the difference between like formally studying those things or even knowing like the official academic language around those things and understanding the concepts underlying them is sort of different. Like I don't actually know what you mean by category theory, but I bet if we talked about it for a minute, it's probably something that I understand and I just don't have that word for.
Yeah, yeah. I think as software developers, we're a field where we learn a lot on the job. And so, sure, you might learn some of these things if you're doing a CS degree, but also when you're doing a CS degree, you're usually doing it very young and very early, and sometimes even entirely before your career as a programmer. And so, you're still in that just memorization phase of learning, and you might not get as much value out of the theory parts because you're just sort of memorizing facts and you don't have a framework to sort of fit it into.
Yeah, or it's just like detached theory floating in your textbook and your brain without necessarily a good way to apply it to the real world problems that you're seeing. I think it's just a matter of like two different directions, maybe not just two, but did you learn the theory and then figure out how to apply it to the real problems you're facing? Or did you just start solving real problems and through that process develop an understanding of the theory, whether or not you have the same terminology? And I think they're both super valid approaches and that most of us do a little of each.
I'm just sort of processing this in real time, and now I'm seeing almost like an image of like a triangle of sort of three parts of our job that are sort of always maybe in tension or in balance. One of which is just sort of a knowledge base, facts that we have to memorize.
Mm-hmm.
Another one is theory, sort of ideas, lenses through which we can look at the world and understand things. And the other one is sort of raw, just critical thinking and knowing how to break down problems. And maybe sort of those three things are maybe the core parts of software. But maybe the public perception of our job is sort of over indexing the just fact knowledge, the like
Mm-hmm.
memorization of syntax.
I think that's a really good way of putting it. And I think you can build up all three vertices of that triangle in a lot of different ways, in like, pure studying of theory, researching, reading a lot, experience, conversations, like all of those contribute to all three of those vertices in different ways that can all be really important. And I think, I just keep thinking about the different ways that people come to this career, that some people start out with like, computer science degree and then move into like creating actual software and developing it that way. And some people start with learning just enough code to do the thing that they want to do and then building on that. And at some point in that development, you can't really tell the difference between those two people anymore. Although early on, it's very clear.
Yeah, I mean, everyone has their own journey. Everyone's going to build up a little bit of those vertices, I think, in different areas. And I think each of those vertices on the triangle also sort of depends on the other two.
Mm-hmm.
So, making critical thinking decisions, you might use a mental model or a theory on the theory end of things to help you sort of filter through ideas. And you definitely need a lot of sort of low-level data and facts to make that decision. And then that will impact your critical thinking sort of decisions. On the other hand, maybe you have a bunch of like facts and data and you've made a critical decision. And now you're starting to see patterns emerge and you say, hey, I tend to make this decision in these situations. Now you're starting to build up a heuristic and maybe that fits under your sort of theory node and just sort of building that up using the other two. And, sort of, I feel like every node can sort of benefit from the other two.
Yeah. They're not totally distinct dots. They're vertices of a triangle. They're all connected.
Well, there's definitely a lot to chew on there.
Yeah.
And what are we is probably a existential question that we all face at some point. But I think we are at the point where we should probably cap this off. So on that note, shall we wrap up?
Yeah, let's do it.